Okay, now let's move to infinite limits as x approaches a and the vertical asymptotes. So now, there are two cases that we want to look at. Case 1, now let's consider the graph of a function 1 over x, and then in the next case we'll consider the graph of the function 1 over x squared. So what if we consider the graph of a function 1 over x, and let's have some points. We got x, we got y. What if x takes on some values? What if we say x is 1? If we put 1 here, we're going to have 1 over 1 is 1, right? Y will be 1. What if we say x is 0.5? Right? Or maybe we could start with 2. X is 2. 1 over 2 is 0.5, right? So you have this will be 0.5. When x is 1, or maybe we could say 1.5. When x is 1.5, what do we have? 1 over 1.5 is like saying 3 over 2, meaning 1.5. So this is 1 times 2 over 3, right? You reciprocate, it's 2 over 3. So 3 into 2, 3 into this, you add a 0 to this, 3 into 20, it goes there. 6 times 3 times 6 is 18. So you subtract, there's a 2, so it's going to be 0.666666. Now let's say you have your x to be 1. When x is 1, you have y to be 1. When x is 0.5, assuming you have 0.5 down here, which is 1 over 2. So it's like 1 times 2 over 1, reciprocal of the fraction down here. So it just equals to 2. And then we have, so let's take positive, negative numbers now. Or let's take some other smaller numbers. Let's say we have 0.1. If it is 0.1, you're going to move this thing 1 times and you add a 0 to this, so it's just 10. So this will be 10. What if it was 0.01? This is 10. 1 over 0.01. You move this thing 1, 2. You add 2 zeros here, 1, 2. So it's 100. So this is going to be 100. Right? Now, let's take some negative numbers. Let's say x is negative 2. Y will be negative 0.5. It is just a negative that is changing, right? What if x is negative 1.5? Y will be negative 0.6. What if x was negative 1? Y will be negative 1. What if x was negative 0.5? Y will be negative 2. What if we had our x to be negative 0.1? Y will be negative 10. Okay. Now let's plot these points on a graph and study the behavior of the graph. So let's have a graph like this. So now we have this to be, we're going to have this to be 1. We're going to have this to be 2. Likewise, we have 1 minus 1. We have minus 2. Likewise, we have, so this side now we can say this is 10, 20, 30, 40, and so forth, right? So let's see the y direction. Okay. So we call this 5, 10, and so forth. We call this 5, 10, and so forth. Now the first one says when x is 2, positive 2, we move to 2. Y is now 0.5. So 0.5, say this is like 2.5. Say this is, you have 1, you have 2, you have 0.5. So let's say this is 1, this is 2.5 there. So there is 1, and this is 0.5. So 0.5 is found between here. So we have like when x is 2, y is 0.5, around there. When x is 1.5, y will be 0.6. When x is 1.5, assuming between here, 1.5, y will be 0.6. So 0.6 now is slightly above 0.5. So it will be 0.6. So when x is 1, y will be 1. So you have it like this, also 1. So this one is a bit lower. When x is 0.5, y is 2. When x is 0.5, is right here. Y is now 2. 1, 1, 2. So y is now 2. We have it right there. When x is 0.1, y is 10. When x is 0.1, so if this is 0.5, you have 0.1, 0.2, 0.3, 0.4, 0.5. So you have 0.1 around here. So this is 10, right? So we can have something like this. You know, this line that I straight up. So we straighten out a bit. Okay, so we have something like this. So now let's follow this kind of pattern from this direction. So you understand that this thing will go like this. It will connect with a lot of points on this line. It will connect like this. It will connect like this. And it will keep going and so forth. Right? Now let's look at the negative portion. When x is minus 2, this is minus 2. Y is now negative 0.5. So when x is minus 2, y is negative 0.5. So assuming that you have negative 0.5 around it. So that is, so when this is minus 2, it's negative 0.5 around here. When x is minus 1.5, now this is 1. So minus 1.5 is between here. Minus 1.5. What is y? Y is negative 0.6. So 0.6 now is just slightly below this one. So put negative 1.5. So this is, if there is 0.5 now, this is now 0.6, slightly below it. Now when x is minus 1, it's minus 1. Y is minus 1. So minus 1, we can consider this to be our minus 1. So this is now minus 1. When x is negative 0.5, negative 0.5 is right between here. Negative 0.5. What happens to y? Y is minus 2. So minus 2, we're going to have it like 1, like 2. So we have minus 2 to be around here, assuming. Now when x is negative 0.1, when x is negative 0.1, this is negative 0.1 around here. So it's negative 0.1. Y now is negative 10. So we consider this one down. We put this negative 10 on the side, so we mark a point right here. And that continues. So if we connect these points, we're going to have something like this. We're going to have something like this. Now, what do we observe from our graph? We observe from our graph that as x is getting closer and closer to, now this is 0, right? Negative 1 and positive 1. When as x takes on some values, some positive values from this end and coming towards 0, getting closer and closer to 0, you observe that the numbers are increasing. So let's say we have 0.1 is 10, 0.01 is 100, 0.001 is 1000. So as x is taking on some smaller numbers, as x is approaching 0 from the right hand side, when x is approaching 0 from the right hand side, what happens? The entire function 1 over x will be increasing. So we can explain that using a limit. So we say the limit of 1 over x, as x is approaching 0 from the right, this whole function now will be increasing, right? So we'll be approaching positive infinity. That is, when x is now approaching 0 from the right. This is 0, the origin. So when x is taking on some numbers, as it is coming here like this, as it is getting closer to these numbers, you see that the function is increasing. It's going up, all the way up. Also, the limit of the function 1 over x, as x is taking on some numbers from the left of zeros. From the left of zeros. So as x is taking on some numbers and going towards 0, what happens? The function now will be increasing. So as x is getting on these numbers, -2, -1.5, -1, -0.5, 0.1, 0.001, you find out that the function is decreasing. It is going downward. It is decreasing. That is, this whole thing is approaching negative infinity. So this is the interpretation of this graph. Now let's look at case 2. Case 2 says, consider the graph of the function 1 over x squared. Now, this function, right? We want to consider the graph of this function. This is the graph. This is the coordinate system. We want to draw the graph there. So let's select some arbitrary points and study the behavior of the graph after we have plotted these points. If x is 1, if we put 1 in this, we're going to have y to be 1. Because 1 squared is just 1, right? Now when x is also -1, we're going to have -1 times -1 will give us positive 1. Y will also be 1. Now when x is 1.5, let's say we have 1 over 1.5 all squared. So it's 1.5 times 2, or let's say times 1.5. 5 times 5 is 25, 5 times 1, 5, 6, 7. So it's 5 is 1. So it's 5. This is now 12, right? This is 2. So it's 1, 2, 2 places, 1, 2 places. So it's 2. So this now will be 1 over 2.25. So if we divide it, we're going to have 2.25 divided by 1. So what we do is that we move this thing 2 places, 1, 2, and we add 2 zeros to this. So it's now 225. Can 225 go into this one? No. We add a 0 to this, we put a decimal point right here. So 225 down into 1,000. So we have, assume we have 4. 4 times 5 is 20. And then 4 times 2 is 8. 9, 10. 4 times 2 is 8 plus 1, 9. So it's 900. So 900 from 1,000 now is 100. Again, we're going to add 1,000, let's say 0 to it. So we will just be getting 0.4, 0.4, let's say 0.4444444. So now it will be 0.4. Put a bar on top of it. What if x was 0.1? Now remember now, if this 1.5 is 0.4, this negative 1.5 will also be 0.4. Right? Because if you multiply negative 1.5 2 times, is going to give you a positive value. Now 0.1, when x is 0.1, what do we have? So we expand this 0.1, that is to say we multiply this 0.1 by itself. So 1 times 1 is 1, 1 times 0 is 0, 0 times 1 is 1, 0 times 0, let's say 0 times 1 is 0, and then 0 times 0 is 0. So we're going to have 1, 0, 0. So we'll move this in 1, 2 places, so it's 1, 2. So we have 1 over 0.01. So if we move this in 1, 2, we're going to add 2 zeros to this. So it's going to be like 10, and then divided by 100. So 10 now divided by 100, 10 into 100, it goes at 10 times, right? So 10 times 100 is, 10 times 10 is 100. So therefore, when x is 0.1, we're going to have y to be 10. When x is negative 0.1, we're also going to have y to be 10. What if x is 0.01? What if we replace this x down with 0.01 and then we square it? So it's 0.01 times 0.01. So it's 1, 0, 0, this is 0, 0, 0, this is also 0, 0, 0. So it's 1, 0, 0, 0, 0. So we check the number of places 1, 2, 3, 4. So you have 1, 2, 3, and 4. 4 places, right? So therefore we're going to have 0.0001. So this now is 0.001. Another 0. So we move this thing 1, 2, 3, 4. We add 1, 2, 3, 4 zeros. So we're going to get 10,000. So when x is 0.01, y is now 10,000. When x is negative 0.01, y is 10,000. See that? So let's plot. When x is 1, we have y to be 1. When x is 1, y is 1. So we have 1 around here, right? When x is, now, this is positive side, this is negative side. When x is minus 1, y is positive 1. So it's like this. When x is minus 1.5, this is minus 1.5. Y is positive 0.4. So this 0.4 is around here. Again, when x is positive 1.5, 0.4. So it is also this 1.5. So this is around here also. When x is 0.1, y is 10. So when x is 0.1, 0.1 is here, y is 10. So y is 10 around here. When x is, look here, when x is negative 0.1, y is positive 10. When x is negative 0.1, y is positive 10 around here also. So you will not say that this thing just goes like this. Just if you connect them, it's like similar to like this, something like this. So what you understand is that from the graph, as x is getting closer and closer to 0, as x is approaching 0 now from the left, when x is approaching the 0 from the left, as x is getting closer and closer to 0, what happens? The function now is increasing. So it means the function is increasing. So that is to say, the limit of the function 1 over x squared, as x is getting closer to 0 from the left, the entire function is now increasing. Similarly, as x is approaching 0 now from the right hand side, the function is also increasing. If the function was decreasing, it would have come down like this. It would have been like this. But because it is increasing, so it shifted in this direction. So the limit of the function 1 over x squared, as x takes on some values that are approaching 0 from the right, this entire 1 over x squared function will now be positive infinitive. So this is the behavior of the graph of the function 1 over x squared. Now from previous graph that we just analyzed, as it relates to infinite limit as x approaches a end of vertical interval, we now derive two distinct theorems. Now the first theorem states that if n, that is to say, if the power of x minus a is just a positive even integer, then the limit of 1 over x minus a all raised to the power n as x approaches a from the right is just equal to positive infinitive. Likewise, if this n is a positive even integer again, the limit of this same function now as x approaches a from the left is equal to positive infinitive. So the both of them will be positive infinitive. And then x minus a equals to 0. X is equals to a is referred to as our vertical asymptote. Also, Theorem 2 says that if n is a positive odd integer, this one is even integer. If n is a positive odd integer, then the limit of 1 over x minus a raised to the power n as x approaches a from the left is equal to negative infinitive. So if this is odd, and then when x is approaching a from the left, it will be negative. If this is odd, and x is approaching a from the right, it's going to be positive. So from these theorems, we now solve these problems. What if you are given the limit of 1 over x minus 2 as x approaches 2 from the left? We know that this thing is infinitive, but we want to know as to whether it is negative infinitive or positive infinitive. So we apply the theorem. Now, let's consider our n right here to be 1, right? This is 1. Our n now is 1. So is it even or odd? This is odd, right? So we now deal with the second case, the second theorem. In the second theorem, we say if n is a positive odd integer, then now is it approaching a particular value from the left or right? From the left, right? So we take the first one. The limit of 1 over x minus a raised to some n as x approaches a from the left is equal to negative infinitive. So this whole thing is just equal to negative infinitive. Meaning this is our a, and then x is approaching a from the left. That is 2 from the left. It's negative infinitive. So now, what will be our equation, if possible, the equation of the vertical asymptotes? So the equation of the vertical asymptote would just be equal to x minus 2 is equal to 0. So let's solve now for x. We have x now to be equal to positive 2. Positive 2 is that number that makes the entire denominator to be 0 and makes the entire function to be infinitive or undefined. We'll move to the next one. The limit of 1 over x minus 5 raised to the power 4 as x is approaching 5 from the left. So is the power even? Yes, the power is even. So when the power is even now, then we check as to whether x is approaching a particular value from the left or the right. So x is approaching this value 5 from the left. So we consider this one. Right? We consider this one. So when n is a positive even integer, that is n is now an even integer, then we have 1 over x minus a. A now is representing 5. So x minus 5, all raised to the power 4, as x approaches 5 from the left, will just be equal to infinitive. So this whole thing is just infinitive. Now, what is our equation, if any, of the vertical asymptote? So you have x minus 5 is equal to 0. So x now is equal to positive 5. Now the last one. Now the first thing you must do is to ensure that in the numerator and the denominator there is no common factor. If we look down here, we can factorize the denominator. So first get rid of the common factor. X approaches 2 from the right. Because the coefficient of this quadratic term is just 1, so we're just going to expand this first term x times x to give us s squared. Then we move to the last term. Which two numbers can we multiply to give us minus 6? If we add those same numbers, we're going to get positive 1. So we know that 3 times 2 will give us positive 6. So in order for us to get a positive 1 here, we put a positive to this 3, and we put a negative to this 2. So one is positive 3, and one is negative 2. So you look up here, x plus 3 and x plus 3 go out. So therefore we have the limit now of 1 all over x minus 2 as x approaches 2 from the right. So this whole thing is raised to the power of 1. So the power is odd. Now if the power is odd, positive odd integer, then the next thing we'll look as to whether x is approaching this value from the right or from the left. X is approaching 2 from the right. So we consider the right quotient. So when x is approaching a from the right, the function 1 over x minus a all raised to the power n will just be equal to positive infinitive. So this whole thing is just positive infinitive. What is our known equation? We have x minus 2 is equal to 0. Therefore, our vertical asymptote now will be x is equal to positive 2. Now let's look at some supplementary problems. In addition to the previous problems we did, these are problems that you're going to practice. So what I'm going to do, I'm just going to take one from there and solve it, and then the rest will be left for you to practice. So these are all similar problems that we just from doing. So you can now practice all of these problems. So let me see. I'm doing question 7. So question 7 says the limit of 3 plus y all over y squared minus 9 as y approaches 3 from the right. So now we have 3 plus y all over, we factor the denominator. So it's y times y is y squared. 3 times 3 now is 9, negative, and positive will give us 0 because the middle term is 0. As y approaches 3 from the right. So 3 plus y is the same as y plus 3. So now we will have 1 all over y minus 3 as y approaches 3 from the right. So the power here now is just 1. So when the power is odd, and then x is approaching a particular value from the right, the power is odd. The fact that x is approaching a particular value from the right, that thing will just lead to positive infinitive. So now it is positive infinitive. We said we should find a vertical asymptote or any equation. So we have y now minus 3. Remember the vertical asymptote is that value that takes the denominator to 0. The denominator, as long that number can make the denominator to be 0, that is the vertical asymptote. So equate the whole denominator to 0 and solve for the variable. So y now will be equal to positive 3. So the vertical asymptote is y equals to positive 3. So the rest of the other problems now you can practice them. They are very simple for you to practice.